You are in the empty sky, high above an endless, featureless ocean. There are no landmarks.
No coastline. No scent of land on the wind.
Below you, the sea is a uniform, rolling blue.
Above, the sun is a brilliant, blinding marker, but it tells you only the time of day.
Not your place in this vast emptiness.
Your world is stripped of all conventional signposts, reduced to an invisible challenge: migration.
You feel a pull, a persistent, three-dimensional knowledge of a single spot 10,000 miles away.
But this knowledge is not a thought. It is a sense. How do you follow an invisible map across the entire globe? How do you navigate a world defined not by what you see, but by a force you can feel?
This is the sensory reality of the Arctic Tern, Sterna paradisea, the greatest long-distance migrant on Earth.
We are not just observing its journey, we are decoding its Umwelt, the unique perceptual world it inhabits.
Here in the lab, we can analyze the problem. For any navigator, latitude is the easy part. The angle of the sun or the height of the stars can give you that.
But longitude, your east-west position, is a puzzle of immense complexity.
It requires knowing the time at a fixed point, a home longitude.
Humans solved this with hyper-accurate marine chronometers.
The Tern solved it with quantum physics.
The Tern's compass is not in its mind. It is in its eye.
Within its retina, the royal tern possesses specialized proteins called cryptochromes. When a photon of blue light enters the bird's eye, it strikes one of these molecules, triggering a quantum reaction. This creates a radical pair, two molecules briefly linked by a shared electron.
This link is incredibly sensitive. The Earth's magnetic field, the very lines of force that encircle the planet, directly influence the behavior of these electrons.
The radical pair mechanism is how the electron spin, influenced by the Earth's magnetic field, allows the Tern to literally see the field lines.
We hypothesized that the Tern doesn't see a red arrow pointing north.
Instead, it likely perceives a pattern, a filter of light and shadow, or perhaps a color shift, superimposed over its normal vision.
As it turns its head, this pattern shifts, strengthening or fading.
This overlay allows the Tern to visualize the inclination and intensity of the magnetic field lines.
It isn't just seeing a direction, it is seeing its position on a global magnetic grid.
We can simulate the physics, but we cannot simulate the instinct.
To understand this map, you must use it to survive.
The lab fades. The human world of right angles and solid ground dissolves. Your vision sharpens, becoming an order of magnitude more precise than a human's. But simultaneously, a new layer asserts itself. As you tilt your head, a faint, polarized shimmer overlays the world, like a wash of watercolor. It's strongest in the blue light of the periphery.
You look toward the sun, and the pattern is muddled.
You look away, toward the poles, and the pattern resolves. It's not a line, it's a slope. You are no longer just seeing the sky. You are perceiving the planet's magnetic inclination.
The angle at which the field lines dip toward the Earth.
This is your map. Your flock lifts from the Arctic gravel, a whirlwind of white and gray.
Hunger and the changing light are the triggers, but this new sense is the mechanism.
You launch out over the cold North Atlantic. The pull is immediate.
It is not a thought. It is an itch, a deep cellular alignment.
Your body knows the destination, a specific magnetic signature 10,000 miles south.
Your task is simply to keep this internal, visual pattern at a specific orientation.
When the pattern drifts, you adjust course. You are locked on.
For days, the sun is your clock, helping you compensate for the Earth's rotation.
But the magnetic map is your longitude.
You are holding a steady course, following a specific contour of magnetic intensity.
You are not just flying south. You are following an invisible highway in the sky.
Then, the world changes. A wall of towering cumulonimbus clouds.
A cyclonic storm, hundreds of miles wide, boils over the ocean, directly blocking your path. The wind screams. Rain and spray become a single, blinding chaos.
To a human, this is disorientation. It is vertigo. It is death. Your vision is useless. The sun is gone. The stars are gone.
The horizon itself is a churning mix of water and air. But as the visual world dissolves, the other sense becomes dominant. The magnetic map shines through the chaos. The storm does not bend the planet's magnetic field. The rain cannot wash it away. It is as stable and clear as it was in the bright Arctic sunlight.
You are buffeted by turbulence, your small body fighting the wind, but your direction is never in doubt.
The internal, shimmering pattern holds steady.
You feel the pull of your route, the path of least resistance. You sense the correct inclination angle far to the east.
The storm is a physical barrier, but the map provides the detour. You stop fighting the headwind and turn, letting the wind carry you. All the while keeping that internal, quantum-generated pattern precisely balanced.
You are not navigating through the storm. You are navigating around its massive western edge.
You skirt the edge of the eye wall, a place of pure physical violence.
But in your sensory Umwelt, the path is calm.
You are riding the invisible contours of the magnetic field,
treating this terrifying meteorological event as just another obstacle, like a mountain range to be flown around.
For 72 hours you do not see the sun.
fly, rest on the churning water, and fly again.
Guided only by the quantum state of molecules in your retina. The world is reduced to two things: the physical force of the wind and the unwavering, directional pull of the Earth's field.
Then, as suddenly as it began, you fly out from under the cloud shield. The sun reappears, a welcome, familiar calibrator.
You check its position against your internal map.
You are hundreds of miles east of your original track, but you are not lost. You cannot be lost.
You simply reacquire the correct magnetic address and bank south.
The storm is behind you, a problem solved by a sense humans can barely comprehend.
You have crossed the equator. The map inverts.
The magnetic lines you were following down into the northern pole now slope up from the southern pole.
Your entire sensory filter reverses, but the instinct is the same.
The pull toward the Antarctic feeding grounds is relentless.
You are a living needle in a quantum compass.
A speck of life, perfectly attuned to the fundamental forces of the planet.
The simulation fades. We are back in the lab, but the world itself feels changed.
That insistent pull is gone. For the Arctic Tern, the Earth is not a solid, inert globe navigated by memory.
It is a living, dynamic web of forces, a tapestry of magnetic contours, as visible and tangible as a mountain range.
Its 10,000-mile journey is not a feat of endurance. It is an act of perception.
The common tern's entire reality is filtered through a sense that taps directly into the quantum structure of the universe.
We have just navigated the planet using a living quantum compass. But this is only one Umwelt, one hidden layer of the world.
We've only begun to understand their world. What about the low-frequency rumbles used by elephants to communicate across miles?
Or the ability of a bee to see the polarization of light?
What hidden layer of reality should we simulate next? Let me know in the comments.